Okay guys, so we're going to start chapter 5. I'm going to warn you ahead of time, I'm trying something a little bit different with having the picture here, so it might look a little goofy and you'll see my eyes go all over the place, which is, I guess, pretty normal. You get used to it. Okay, so starting with chapter 5, we're going to kind of break this down into smaller segments. So in the process of breaking it down into smaller segments, I want to make sure that we're getting the major pieces. So our major pieces are looking at some identification pieces. In this case, we're looking at those really large biological molecules. We're going to continue to use these throughout the year, so therefore we need to really have a basic understanding right now so that we can move into how we actually use them as we get into further units. So this very first one is really just kind of breaking down what we got and what it looks like. So what we're looking at is we look at the idea of a macromolecule. Now I know you guys heard about macromolecules in regular biology. We're going to go back through this to kind of have it in your head. So when we're looking at a macromolecule, what we're talking about polymers. So polymers are really simple in the fact that the idea behind them is really easy. It's long molecules that are going to be either really similar or identical building blocks. So they're going to have really identical or really similar little pieces that put together to create a big piece. And so as you can see in this picture right here, we talk about a short polymer, we talk about 1, 2, 3 here. These three pieces are part of a polymer. Now this polymer, when we're looking at it, is only made up of 3 smaller monomers. Monomers are going to be that repeating unit or those similar units. So this is the easiest way to think of a polymer is kind of like a train. So think about all those cars being the pieces or those monomers to create that polymer. Now the interesting thing about creating a polymer or breaking down a polymer, we talk about synthesis of a polymer or breaking down of a polymer, we have to talk a little bit about chemistry. So we went through, we talked about those bondings and we talked about how bonds form and how they break in previous chapters. So now what we're looking at is we're looking at the idea of how we actually synthesize a polymer. The first polymer that we're the idea of dehydration, meaning that we're taking away water, but when we think about it, we're actually seeing that we're making water. So it becomes a little difficult to think about. Think about the idea of dehydration, pulling that water out of the reaction, out of the structure that we're trying to create. And that creates our synthesized polymer, where it's going to be a longer piece made up of more monomers. Now, so then vice versa, we talk about the idea of a hydrolysis. Hydrolysis is going to be breaking down that polymer, and when we're breaking down that polymer, what we're really doing is we're going to be adding lots of water to the to that polymer, and because of that, we're actually able to create a bond that will break. Think of it as being as a reverse of dehydration reaction. If you take the actual word hydrolysis and break it down, hydro means water, lysis, lyse itself means to cut. So we're talking about cutting using water. So we're cutting apart using water. So this is important to make sure that we understand before we can get into the idea of looking at those macromolecules. So that leads us into our first macromolecule. Our first macromolecule are carbohydrates. When we look at carbohydrates, we talk, and you guys already know carbohydrates because of talking foods. At any point of your life, you've heard about carbohydrates. Carbohydrates are simply sugars, or polymers of sugars. So we talk about the most simple being our monosaccharide. Okay, so our monosaccharide is the most simple. It's considered a single sugar. Normally we're going to show it, and we're going to talk about the fact that it is going to be, we'll show it in a line like this. We talk about linear and we talk about ring forms. When we look at monosaccharides, we always talk about the fact that they come from a base unit, and the base unit is C, carbon, hydrogen, 2 of them, and oxygen, so CH2O. So we talk about the fact that there are multiples of this to create our sugars that we're looking at. So here's examples that we can look at of sugars. So we look at aldoses, ketoses. We talk about those trioses. We look at there's 3 carbons, which means we're looking at 1, 2, 3, 4, 5, 6 hydrogens, and then 1, 2, 3 oxygens. So we're staying true to that CH2O form. So we have 3, 6, 3. It's always going to be in that ratio when we're talking about our carbohydrates. Now, the interesting thing about monosaccharides is that usually we look at them and we talk about them in this linear form, but this linear form is not really realistic. Usually. Sometimes it is, but for the most part, when we talk about something that is a carbohydrate, if it's in an aqueous solution or if it's in that water solution, we talk about the fact that it actually will form and create rings. And those rings become really important because that structural change or that look is going to allow for it to bond in a little bit of a different fashion. And that's going to become important to us as we're going through. Okay, so our next one that we look at is the idea of disaccharides. So di obviously means two, so we're looking at two monosaccharides being put together. And these guys are going to be held together with glycosidic linkages. Now those glycosidic linkages we're talking about is a covalent bond that's going to be formed by that dehydration reaction. So when we're looking here, and we actually can see this example right here, we talk about the fact that we've got one glucose molecule, and we're actually able to create that water form to create a new glycosidic link, and that's going to be formed, that bond between that oxygen that's going to hold those two glucose together to create what we call maltose. If you haven't remembered this yet, you're going to hear lots of oses. Anytime you hear an OSE, think sugar. So this is another example when we're looking at that dehydration reaction. We talk about glucose and fructose to create, and you guys all know this one, sucrose. So again, this is how we're forming it with that dehydration reaction to create that glycosidic linkage. And now we're talking about the name of the linkage here. We're saying where it actually is formed, and that's going to be at that 1, 2 site. So this one is going to be at a 1, 4 site. So when we number, when we get into, those of you guys who have taken chemistry have already seen that bond, and you number your carbons in your organic rings or in your organic molecules. And the same thing is what we're looking at here. This is going to be at site 1, this is going to be at site 4. This one's at carbon 1, and this is at carbon 4. Okay, so here we're looking at the idea of a disaccharide. Well, our next big one then is going to be what we refer to as a polysaccharide. Well, obviously poly means many, so we're talking about more than one. In fact, we're talking about more than two. Usually we talk about these macromolecules, and we talk about the fact with polysaccharides, oftentimes we're looking at those polymers that are actually going to be a few hundred to a few thousand monosaccharides that are going to be put together. And they're all going to be formed by still those glycosidic linkages. Oftentimes when we start talking about polysaccharides, we talk about them in different forms. We talk about them in storage, and we also talk about them in structure. So when we talk about storage material, we talk about the fact that that storage material is going to become hydrolyzed. Remember, hydrolysis is going to be adding water to break those bonds, and as we break those bonds, we're actually getting to the point of being able to pull apart those individual pieces so we can break them down and use them for the energy that's necessary. Okay, so we've got this storage material. Storage material looks a little bit different depending on what kind of living organism we're looking at. We've got plants, our big group, and we have animals as another big group. Our first one, if we look at plants, we often talk about starch. And you guys know this because we talk about starch being something that we intake as animals. The starch that we're intaking is coming from those plants. Now, that starch is going to be glucose monomers. They're going to be little tiny pieces that are all made up of glucose. There's going to be hundreds to thousands of them all put together, and then where they're actually able to use that as storage. And where they store them in plants is called plastids. And there's different types of plastids, and they store different types, I guess, of starch molecules so that they can be used in different things. Now, the animals, we talk about the fact that they still store, but they don't store in the form of starch. We talk about them storing in the form of glycogen. Glycogen is the storage unit that's primarily used in animals. It is again a glucose base, but it is a glucose polymer, meaning it's already made up of a lot of monomer pieces to create that polymer. Now, this one's going to be stored primarily in your liver and in your muscles, and because it's stored in your liver and in your muscles, this is where we're going to break down, which is why when we talk about people who are not getting enough carbohydrates or enough starches, or I don't want to say starches, they're not intaking enough carbohydrates, that their body automatically goes to break down what they have, which is why your body attacks your muscles first. Fat storage is not carbohydrates, and your body needs to have those carbohydrates in order to be able to survive. Okay, so our last piece when we're looking at polysaccharides is going to be the idea of structure. Now, structurally, we talk about a couple different kinds. We talk about cellulose, and then we talk about chitin. Let's talk cellulose first. This is a building material. This is really going to be that building material primarily found in plants. Now, there's also a form of cellulose that's found in animals, but first let's talk about plants. Plants use cellulose as their structure. This is actually some of the solid pieces that allow for the organism to actually be able to grow and have stability. So it's a solid piece that they need, and they're going to be long tendrils, long fibrils that will actually run throughout the plant. Animals, we talk about cellulose as well, and the interesting thing about cellulose is we intake most of our cellulose. We don't create cellulose. We take it in, and we take it in obviously through plants. We do actually use it then, and the interesting thing is that we do use it especially in a digestive process. What we see is that we do have the ability of having, not being able to break a lot of it down, but we do rely on, animals rely on microorganisms, those little tiny organisms, to be able to assist in breaking down so we can actually take and use pieces of that polysaccharide. So when we're looking at cellulose, we talk about plants being building, and for animals, really we talk about the fact that it is really going to be broken down and used within that digestive process. Think fiber. Think about how fiber works within your body. All right, the other one that we look at that becomes a structural piece is chitin. Now, chitin is really quite interesting because chitin is going to be found in a few different types of organisms. First, think insects. Insects is the easy one because with insects we talk about that exoskeleton, and the exoskeleton of an insect is going to be made of chitin. Chitin is crazy. It's super hard. It's a structural piece. It doesn't break down very easily, and this is one of those big things for those insects because it gives them their structure, and it also gives them protection. And it is actually made up of, believe it or not, carbohydrates. Now, the other piece, actually another plant, another organism that you'll see it find it in is fungi. Fungi also have chitin in them as well, and again, it's used for structural pieces. It's actually going to be used for growth purposes, so that it can actually grow bigger. It's not just going to be those mycorrhizae, which we'll talk about later. The idea is that chitin is actually very similar to cellulose. It's actually a little bit, structurally it's actually very similar as well. There's just a few different bonding units, and that's what ends up changing the structure of it, and it does have to do with how it's put together. Okay, so this kind of wraps up carbohydrates. The next installment that we'll be looking at, you'll be talking about lipids and proteins, or part of proteins at least. Okay, so make sure that you complete the quiz, and happy days.